Hi everyone, welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you so that we can complete ionic equilibrium today itself. Right? So everybody let me know. Wait a minute. Yes? Everyone, am I visible? Am I audible? Yes, students. So ionic equilibrium, we have already done pH calculation, buffer solution calculation. Now, last two topics of ionic equilibrium, that is solubility and salt hydrolysis, we are going to do today, right? Okay, I think the thumbnail is wrong by mistake here. The thumbnail is wrong, right? Okay, but otherwise there it is correct, right? So we are going to do solubility and salt hydrolysis and salt hydrolysis. So I'll be first talking about salt hydrolysis, then I'll be going towards solubility, right? So let's start it. So if you talk about salt hydrolysis, firstly we need to understand about salts. So if you see salts are the ionic compound. An ionic compound of made up of which thing? They are made up of a cation and they are made up of an anion, right? Where cation is the compound, cation of the compound comes from a base and anion comes from an acid. Now ma'am, how you can say this? Okay, let's see, you have a salt that is NaCl. Now if you see, Na is coming from NaOH and Cl is coming from HCl. So this is positive, this is negative. So anion is coming from an acid, cation is coming from a base. Right? This is just a very simple example. Vanakam, Vanakam. This is just a very simple example that I have given you. Right? Very good. Very good. Remembering easy. Right? Yes, picture. Yeah, whatever your names you have given to your YouTube. Huh? Sanjay, yes, Bharat, Utsav, Abhinya, then Bharat, Dhruv, yes, right? So, cation is coming from base and an ion is coming from an acid. For example, you have NaCl, that I have example that I have just given you, right? Now, salts can be just like buffer solution we categorize. Similarly, salts are categorized, right? Same as buffer solution, salts are also categorized into different parts. And what are these different parts here? If you talk about acidic salt, right, then there is basic or alkaline salt. What is acidic salt? Let's see. Acidic salt is these salts have ionized H positive, right? So ionizable H positive, that means they have ionizable H positive here. Basic salts are they have ionizable OH negative here, right? That means which can ionize OH negative, that is a basic salt, and the one which has ionizable, which can get dissociated H positive, that is acidic salt, right? Salts by complete neutralization of acid and base, right? And these are by salts by incomplete neutralization. So when there is incomplete neutralization, then maybe in acidic salt extra part of H positive you have, in basic salt extra part of OH negative you have. When there is complete neutralization, in that case all the H positive and OH negative are neutralized to form water, and byproduct is you will have salt, right? So basically when you have an acid and you have a base, right? If there is complete neutralization, let's say you have 100 H positive and 100 OH negative ions, all of them are neutralized to form water, right? Then this salt that is formed, it is called as by complete neutralization, right? And they will not, like for example, you have HCl and NaOH. With complete neutralization, they will form NaCl. NaCl does not have any H positive or OH negative here, right? So it is, the salts do not have any ionizable H positive or OH negative like NaCl, Na2SO4, Na2PO4, MgCl2, these are those salts. And if I talk about the salts which are formed when, let's say here, what is happening, complete neutralization is not happening, some extra, with the salt some extra amount of H positive is there, or with the salt some extra amount of OH negative is there, that is called as acidic or a basic salt here. Example is NaHSO4, Na2HPO4, NaHCO3. So H is always there, right? Even in this case, you have MgOH, right? This is ZnOHCl. So it has ionizable OH negative, right? Okay. Now let's talk about salt hydrolysis. Once we know that what are salts and what are different categories of salt, now let's talk about hydrolysis of salt. What are the salts that hydrolyze themselves in the water? Let's talk about that. The phenomena of the reaction of anion, there is a reaction of anion and cation of the salt with the water yielding acidic or alkaline solution is known as salt hydrolysis. Let's say there is some salt here, right? Let's say AX is the salt, this is X positive negative. Now it will react with water, cation will react with OH negative, anion will react with H positive, and it will lead to the formation of acidic or basic solution that is called as salt hydrolysis. That means this salt is being hydrolyzed. Now a very important question is, only the ions coming from weak acid weak base can undergo hydrolysis. This is a very important line, right? This is a base of throughout salt hydrolysis. Why it is so? Only the ion of weak acid and weak base can undergo hydrolysis. The question is, why so? Why only weak acid, weak base? Why not strong acid and strong bases? See, if you have a strong acid, you have a strong base. For example, if I talk about, you have HCl and you have NaOH. Then in this case, all of these H positive and OH negative will be ionized completely. Because they are ionized completely, that is why in the solution, you don't have any extra H positive or extra OH negative ions. And that is the reason, because if in the solution water is having H positive, OH negative, then the salt also should have either H positive or it should have OH negative, so that OH negative combines with H positive and H positive combines with OH negative. Only then hydrolysis is possible. Water has H positive and OH negative, right? What I am saying, that water has H positive and OH negative. If you want this H positive to react with the salt, then there should be some OH negative. OH negative will be there only if it is not being neutralized. And if there is both are strong, then there will be complete neutralization, right? OH negative will react with H positive. It can only do so when this H positive is extra in the solution. That is only possible if there is one of them is weak or both of them are weak, right? So ions coming from strong acid or base undergo negligible hydrolysis. They will not undergo hydrolysis here, right? Ions that are coming from strong acid and strong bases, they will not undergo hydrolysis. When something is undergoing hydrolysis, let's say you have H2O. This is NH4Cl. Now this is coming from NH4. This will be NH4 positive. This is Cl negative, right? When I say in this case, it will form NH4OH and this will form HCl. This is a weak base. This is a strong acid. One of them should be at least weak so that this hydrolysis can take place. Otherwise, the hydrolysis will not take place if both of them are strong. Okay? Right, everybody? Now, let's discuss this one. If I say this is a salt with the water, it is forming an acid and a base, right? we know that this acid is also getting dissociated, this base is also getting dissociated further, right? That thing is happening in the solution, right? Now let's take one examples, that what are the cases. First case is the case of strong acid and weak base. One of them should be weak at least, right? Both of them weak also will work, but strong acid and strong base will not work. That salt will never undergo hydrolysis, right? At least one of them should be weak. Okay, right? Understood now? Now see, example is NH4Cl. In NH4Cl, we know that NH4 positive is a strong conjugate acid. It will react with water. Now, why it is a strong conjugate acid? Because if you see, NH3 is a weak base. That's the reason NH4, after accepting this, it will be a very strong conjugate acid. If the base is weak, its conjugate will be strong, right? So that's why NH4 positive is a strong conjugate acid. That means it can easily lose H positive ions, right? So with water, how it will react? With water, wait a minute, why I'm saying it is acting as a conjugate acid. So it is going to lose H positive, na? Yeah, yes. Okay. If you see this here, this is H positive, this is OH negative, right? NH4 cation, but it will react with the negative part of this. No, if this is a cation will always react with the negative part, right? So what it is going to do, it is going to take OH negative, right? It is going to take OH negative, it will become NH4OH, and H positive will be released by water here, because out of water you are accepting OH negative here. Cation is going to react with anion of this, that is OH negative. Now in this case, I am saying H is the degree of hydrolysis. Just like we used to say alpha is the degree of dissociation, in salt hydrolysis we'll talk about H, that is the degree of hydrolysis, right? So now H is the degree of hydrolysis. This is the same thing that we used to do before. C is the initial concentration, product are 0. C minus initial concentration into degree of hydrolysis. Instead of degree of dissociation, we have degree of hydrolysis. Liquid will not take part in, right? And this is going to be CH, and this is also CH, this is also CH, right? Now, if you see from here, can we say that we need to calculate the pH here. pH is H positive is nothing but C into H, that is concentration into degree of hydrolysis. And overall, what is the value of KH here? KH is going to be C square H square divided by C minus C1 minus H. C1 minus H. So that is going to cancel. It is going to be CH square 1 minus H. Right? If H is very, very small, then it is approximately equals to CH square. Right? So KH is equals to CH square. From that, you can calculate the degree of hydrolysis. That is going to be KH by C under root. Right? That is the first thing that you must remember, that what is the value of KH? It is under root of KH by C. Right? And if you see this here, what is the value of H positive? That is nothing but it is CH. So it is going to be H positive is going to be C under root of KH by C. It will cancel and it will become under root of KH into C. That is going to be the H positive concentration. It is same that we have done before also. Right? Okay. Yes. Tell me. Understood now what we are doing here? Right? H positive concentration is this one. So that's how you calculate the value. Now, let's see KH we have calculated from the earlier in terms of KH and C. H positive also we have calculated here. But KH in terms of Ka, Kb and Kw, now let's focus on that. If you see what is KH? KH is NH4OH. multiplied by H positive divided by NH4 positive. So that means this you can say is the KH, product by reactants. Now you will multiply and divide it by OH negative. This is extra that you are just multiplying and dividing. You multiply something with the 3, you divide it with 3, it is one and the same thing, right? So you multiply and divide it with OH negative. Now this thing is going to form KW, right? And this overall, if you see what is this overall situation here, NH4OH divided by NH4, that means this is nothing but NH4 positive. When it accepts OH negative, it will become NH4OH, right? Okay, this is this. Or you can write the opposite here, that NH4OH, it's a base. When it dissociates into NH4 positive and OH negative. Now when this base is losing the OH negative, when a base loses OH negative, right, that is called as KB. So in this case we can say KB is equals to product, that is NH4 positive multiplied by OH negative divided by NH4OH. That is going to be KB here. Now you know the value of KB here, right? So this divided by this is nothing but this is KB. This is nothing but this is KW. So answer is that KH is equals to KW by KB. So you can write it this over here, that KH is equals to KW by KB, right? You can write it over here, KH is equals to KW by KB. This is important, right? Now we also know that H positive, this we also know CH square is equals to this, right? KH is equals to CH square, this we have already done. Now we know that H positive concentration is equals to C into H. And if you see this here, right, the value of H you have already put here, right? So that is the reason the value of H positive is going to be under root of KH into C. So can you solve the value of this as, here I'll also write the value of H positive. H positive is nothing but it is KH by C. So H is going to be under root of KW by KB multiplied by C, right? Here you can write it as H positive concentration is KH into C. So that will be KH is nothing but it is KW by KB multiplied by C. That is the value of H positive in terms of KW and KB, right? In terms of when, and we are talking about KB when there is weak base. That's why we are answering it in terms of KB, because KB is only possible if it is weak, right? Okay, so here what we have done, this all derivation I'm just telling you so that you understand this thing, how we have KH is equals to KW by KB, right? And then put it here. Now remembering these formulas as such will be tough, so that's why just remember few things here. I'll tell you in the end what are the things to be remembered here. If you see H is equals to KW by KB into C, and this is KW by KB into C, right? So H positive concentration we know here. Now what I'll do, I'll just, this is like in buffer solutions I told you know what to remember. One thing is understanding. Understanding was how ma'am KH is equals to this and this. Now remember one thing here, put if one of them is weak. Here I am writing the trick here. If one of them is weak, what are the formulas that you need to remember? That KH is always equals to KW by whatever is weak, right? H positive is always equals to under root of KH into C, and H is equals to under root of KH by C, है ना? Under root of KH by C. Okay, that's it. These are the three things that you need to remember. Right? These are the three things that you need to remember. Now I'll give you one by one for a strong, when you have a weak acid and a weak base, how to apply these two formulas. Okay, now I'll tell you how to apply these. Right? Now let's see. If you have a combination of strong acid and weak base, this is a combination of weak acid and strong base. Okay? So, if you have a combination of strong acid and weak base, how do you write the formulas? How you remember the formulas? Right? Thala, it will be there in Neat English channel only. You can go and see it. Right? Okay? So, if you see this over here, KH here is going to be equals to KW by weak. Weak is base, so it will be KB. Here, what is this? Here, KH is equals to KW by whatever is weak. Weak is acid, so it will be acid. Okay? Then, if you see what is the value of H positive? H positive is going to be under root of KH. KH is what? It is KW by KB multiplied by C. And what is H? H is equals to under root KW by KB divided by C. Okay? That is the value of H. Similarly here if you have a weak acid, in this case you are actually calculating the concentration of OH negative. So H positive will be replaced by OH negative. I'll tell you why. Right now, just remember on learning KW by KA multiplied by C. This H is nothing but it is again KW by KA. This multiplied by C. Okay. Now see 2-3 questions that might be in your head. Firstly, that this might be in your head, ma'am, how we got this formula. I'll talk about this later. Right. Firstly, ma'am, why for a weak acid you have written OH negative concentration? Wait a minute. Wait a minute. Yes. Why we have written OH negative concentration? Because of this thing here. Right? You have a salt of weak acid and strong base. In this case, what will happen? This anion is going to get attached to the cation, that is H positive, and you will be left with OH negative. Everything is same. Initial is C, C minus CH, CH and CH. So here if you see, OH negative concentration is C into H. And what is the value of KH? That is nothing but KH is equals to C square H square, again C1 minus H, that will correspond to CH square. Right? And H will be equals to same thing under root of KH by C. Right? Now the question is, ma'am, how you can say that the value, wait a minute, H we have written na? I'll just put the value of H here as well. This will become KH multiplied by this divided by this. This will be multiplied by this. Okay? That's how the same thing, why OH is under root of KH into C, why H is that. Okay. Now the question is, ma'am, how can you just directly write that KH is equals to KW by KA? It is also the same thing here. If you see, in this case, product by reactants, write it in that form, product by reactants. Multiply it with H positive and divide it with H positive, right? It will be this thing. Now this is nothing but this is KW. If you take it here, this will be CH3COOH. So that is going to be when CH3COH is dissociated, that is Ka. When CH3, this is the dissociation of, when CH3COOH is dissociated into CH3COO negative plus H positive, then you have this particular thing here, that is Ka. So that's how we have written this as Ka, product by reactants, that is the value of Ka, this is the value of Kw, and that's how you have H of a weak acid is equals to Kw by Ka. Right? Okay. Tell me everybody why I have written it like this. Okay. Once you know this, then tell me one more thing here. Okay, ma'am, this I have already told you about this thing, right? Then this also we have already calculated. I told you why it is so. You don't have to remember all these things here, right? Acha. Now OH is, we know that OH negative is Kw into C by Ka. Okay, that you can remember this directly from this page. I am telling you just to learn this particular page here, right? Rest of the things I just told you for understanding purpose. Now H positive concentration you have, OH negative concentrations you have. Now what we will do here, once you have H positive and OH negative concentrations, right? Easily you can define the value of pH here. H positive concentration was what? H positive is under root of Kw by Kb multiplied by C. This OH negative is equals to, I'll just write the value of POH and I'll make it as simple as possible for you. Right? This is Ka into C. Right? I just remember these formulas. From there I am making these formulas. Okay? Now derivation of pH is actually by taking log and all. So I'll take minus log of H positive. This will become Kw, to take log here. This will come in front, minus half of log of Kw. This is minus half of log of Kc. This will be plus half of log of Kb. So that will become pH is equals to half of Kw plus half of, minus I would say, minus half of, this is not Kw, this is pKw. This will, if you put 1 minus and 1 minus here, minus log of Kb will become pKb. What I am saying here, if you put here, this is minus minus. Instead of plus, you are writing minus minus. So this minus log of Kb is nothing but it is pKb. So minus half of pKb. This is minus half of log of C. Right? In this, on the similar lines, I'll write everything same here. This will become POH. I'll calculate only, chalo, let's calculate only this thing. This will become pH. What is pKw at 25 degrees Celsius? 25 degrees Celsius, it's 14. But I will not write 14 here because if they give you some other temperature, then it might change. So I'll give you pKw only, right? So it will be, take half common, and this will be pKw minus pKb minus log of C. Okay? Okay, got it? Now if you see this on the similar lines, POH, here I'll just write similarly, POH will become half of pKw minus pKa minus log of C. You don't have to, students do this mistake, they learn pH values differently, right? They learn this, then they learn this differently. Why you have to do that? Right? Why you have to learn the pH of all of them? Just remember the value of pH and POH. Just remember this pH. This is nothing but this is pH is equals to half pKw minus pKb minus log C. Half minus pKw minus pKb minus log C. Right? pH is equals to half multiplied by pKw minus log C minus pKb. Here it will be Ka, everything else will be same. Now here you have calculated pH. So what is the value? POH here value will be 14 minus POH. right? Okay, in books you will see this formula. Wait a minute. Hmm. Wait a minute. Let me just give you this formula here. Oh. Strong acid and weak base. And this is the pH. See, half of pKw minus pKb minus log C. And what's the problem that students do? They learn this formula, then they learn this formula differently. Wait a minute. This is for weak base, na? Huh. Then they learn this formula differently, that here it is plus, here it is plus. I am not at all asking you to remember that. Remember that formula only. Why are you remembering this formula? So you don't have to do this. Right? Okay? Tell me everyone if that is understandable to all of you. Right? So I have just deleted all the extra pages here. In case of if you talk about weak base, you have this thing. Weak base means you have NH4 positive, you have H positive. Because of all of these things, you have these formulas, right? And if you have here why KH is equals to KW KB, that also we have discussed. Then we discussed about when you have weak acid. In that case, everything else is same here. But how come you have KH is equals to KW by KA? That also we have discussed, right? All of these things you don't have to see. Just remember these two pages. This is the first page that you have to remember, and out of this remembering part is only this thing, that whenever one of them is weak, KH is equals to KW by whatever is weak, right? H positive is under root of KH multiplied by C, and H is under root of KH divided by C. Then you put all these formulas, you will have this. Here, what you will see, that the value of pH is going to be, you can just write it here, pH is equals to half of pKw minus pKb minus log of C. Okay, because it is Kb and C is there. Here POH has the same value, that is half of pKw minus pKa minus log of C. Once you have calculated POH, subtract 14 from it and you will have the value of pH. Right? Tell me guys. Is that clear? Okay? So you just have to remember this thing. Rest of the things you don't have to remember. Now let's talk about when you have both of them as weak. When both of them are weak, for example, you have this compound that is having CH3CO negative, which is a weak, which is coming from weak acid. This is coming from weak base, right? So both of them are weak. Both the ions of strong conjugate react with the water. Now in this case, what you will see, that both of them will react. This will gain H positive. This will gain OH negative. This will be converted to CH3COH. This will be converted to NH4OH, right? And that will be the overall value. This is initially CC, this is C minus CH, C minus CH, this is CH, CH. Just like alpha, we have just replaced it by H, that is degree of hydrolysis. Now, the value of KH is product by reactant, product by reactant. Water will have, because if it's a pure liquid, so it will be not considered. Now if you see, I'll multiply and divide it by both H positive and OH negative. Now this value is becoming KW, right? This value, this case and this thing, this is becoming Ka. This is, if you put it here, this will become CH3 COO negative H positive divided by this product by reactant. Yes, that is right. If you see CH3 COOH, it is dissociated. This will become CH3 COO negative plus H positive. These are product divided by reactant, so this will become Ka. So that means it will be divided by Ka. And this thing, this NH4 and this OH and this OH, NH4OH, NH4 and this. It is actually NH4OH dissociating to give NH4 positive and OH negative. This is Ka and this is Kb. So this is becoming Kb. So answer, if you see, this is nothing but this is Ka. This is nothing but this is Kb. This is nothing but this is Kw. So answer is going to be Kw by Ka into Kb. Right? So answer is going to be this. This is different. Weak acid and weak base, you can't apply the same trick that we applied there. Okay. So this particular trick that I told you, that you just have to remember these three things, that is only and only valid for if one of them is weak. If both of them are weak, then we consider this thing. Now in this case, if you see, what is the value of KH here? KH is equals to C square H square. This is C common 1 minus H. This is also C common 1 minus H. C, and this will cancel. This will become H square by 1 minus H square. Okay. This will become H square by 1 minus H square. Right. And that will be the value of KH. So H by 1 minus H is becoming this Kw, right? Because KH is what? KH is also equals to Kw by Ka into Kb, right? So you can see this here. Wait a minute. This is actually not the way we are doing it is actually very nice. If you see, what I need to calculate the value of H here. That is the degree of dissociation. Right? Because only then I'll be able to calculate the other things. Right? So I also know that this is equals to what? Kw by Ka into Kb. Right? So this thing is what I got from here. Right? So this is what they are saying till here. Now we can calculate the pH using acid dissociation. Now you have formed acid and base. Both can dissociate because both are weak, right? They will not 100% dissociate, but some amount of dissociation will be there. So the product that was formed here, this product can further dissociate. So what I'll write here, this is CHCCOH, right? This is dissociating into CHCCO negative and H positive, right? Okay. So initially, if I say you have not 100% dissociation, then in that case, I can say that if you have, let's say this is initially CH amount is there, right? And we are saying initially if the concentration of, what was the concentration of CO negative? Initially the concentration was given to be C, right? And this is coming to be CH. Now it is again being dissociated into CH3CO negative. So again this thing will be dissociated into CH3COO negative, right? So what you will write here, you will write here this is CH, right? And this is C minus CH. Okay? Because from the initial value at equilibrium, this much you have subtracted. CH is already being dissociated into CH3CO negative. So that's why from there you subtracted C minus CH, and that will be the equation here. From here you will calculate the value of H positive, that is going to be Ka. Ka is what? This is product by reactant. What is product here? CH3CO. H positive, Acha, from here, what is the concentration of H positive? Just rearrange this and you will have your formula, that is CH3CO into Ka by CH3COO negative. You have just rearranged it. What is the value of this dissociation? That is product by reactant. So H positive after rearranging will be this thing. So H positive is nothing but it is CH3 divided by CH3CO negative. CH3COH is nothing but it is CH, right? So you have written it as CH. This is nothing but C minus this will cancel. So it is H minus 1 minus H. And we have already calculated the value of H minus 1 minus H. That is nothing but it is equals to under root of Kw by Ka into Kb. And you solve this, you get this as your answer here, right? Okay. So guys, I think just give me a second. Someone is at the door. Okay, I'll just come back in a minute. Okay, just give me a second. Okay, so yes, everyone, let's see what we were doing. We were doing basically how this derivation and all I just told you because you should know how we got into this conclusion. But in the end, I would just say you to remember few things here, that H positive in this case is not equals to under root of KH multiplied by C, but it is equals to only uh, Ka multiplied by under root of KH. Okay, I'll just write it here, right? So you can make one more thing here that says if both of them are weak, if both of them are weak, right? If both are weak, then what you will say? Let's see that. Then how you will write it, right? So if both are weak, you will first say if both acid and base are weak, then KH is equals to KW by weak, because now both are weak, so we'll write KW, K and KB both. But here you will not multiply it with C, right? It is just under root of, it is just H positive is Ka into under root of KH, right? And what is the value of H if you see here? What is the value of H? You will find it here that H, if I ignore this part, if I take this as, if H is very small, then H is equals to nothing but it is under root of KH, right? So in this case, it is nothing but H is equals to under root of KH, not C. So it will be just under root of KH. Just remember this part. You don't have to remember the derivations and all. That is, it will not be useful in the, if I talk about the exam perspective, right? But I still told you, I showed you how derivation is done so that you know that how actually the sequence is going on, right? The sequence is that, but this is what you have to remember in the end. If you see this here, this is H positive is equals to, what is the value of KH? KH is equals to KW by KA into KB, because both are weak here. H positive is equals to under root of, this is Ka multiplied by under root of Kw by Ka into Kb. So if you put it here, it will be cancelled and it will be converted to H positive equals, or you can just put it here, H positive is equals to under root of Ka multiplied by Kw by Kb. But you don't have to remember this, just remember this part, that H positive is Ka into Kh, Ka into under root of Kh. Kh is Kw by weak, right? From there you can easily, within seconds you can calculate. Here chances of mistakes are going to be less, right? So H is nothing, H, so we know that H is equals to what? H is equals to under root of, I can just put here, H is equals to under root of Kh, that is Kw by Ka into Kb. Now when you solve the value of this one, right, this will become minus of log of H positive. This will become minus half of log of Ka minus half of log of Kw minus of minus half, because when you go, when it will be in the, it will be minus half, right? Because it will go in the numerator. Instead of half, it will be minus half. That's why I have put minus half. And extra minus I am putting myself, right? So minus of log of Kb. So this in turn will turn out to be, this is pH is equals to half. This is pKa plus pKw, right? Or you can just say pKw plus pKa minus pKb. It is not at all dependent upon any concentration here, right? It is not at all dependent upon any concentration here. So in the end, all you have to remember, right? In the end, all you have to remember is these three cheat sheets that I just told you, right? These three, 1, 2, and 3. These are the three sheets that you have to remember for your exam point of view, right? Rest of the things you don't have to remember, right? Okay, tell me. Is that clear to all of you or not? What you have to remember in the end for your exam? This part, when one of them is weak, this part you have to remember. Rest of it you don't have to remember. You can easily calculate that in the exam. But I would advise you to calculate the value of, to remember the value of pH and POH. pH in case of when base is weak, when acid is weak, when both of them are weak, then what is the value of pH here, right? This is what you should remember, right? Okay, right, everybody, tell me if that is clear, right? Beta, can you please stop learning something, huh? Instead of doing this and that in the chat box, right? This also is about derivation that I have already explained you, right? But you don't have to as such remember this, but yes, you must know from where it is coming, right? Okay. Acha, now see this thing. Ma'am, we have calculated the pH like this. pH is equals to half of pKw plus pKb minus pKa minus pKb. Now see one thing, these three cases, right? Based on these three cases, they can ask you the question in case of weak acids and weak bases. When you talk about pKa is greater than pKb, in that case, what is happening? When you talk about pKa is less than pKb, then what is happening? When these are equal, then what is happening? So if you see, if I say pKa is greater than pKb, that means I can say that Ka is less than Kb. Acha, firstly, let's see it from the formula. If pKa is greater, this overall value will be added positive. So that means this is already 14. This is 14 by 2. It is already 7. It is actually 7 plus half of pKa minus pKb. So if I say this value is positive, then you will add something here. That means it will be greater than 7. So pH is going to be greater than 7. That means it is going to be a basic solution. If I say that, ma'am, here in this case, you can also write it as pH is equals to 14. I'll just write here minus half of, no, it will be plus half of pKa minus pKb. If I say that pKa is less, that means if this is less, then this overall value will be negative. That means something will be subtracted from this 7. Something will be subtracted from this 7. So why I have put 7 here? Because 7 by 14 by 2 is 7. Na? So it is something would be subtracted from here. That means pH will be less than 7, which is for a basic solution. Wait a minute. This is acidic. Okay, let me just correct it. This is going to be acidic, right? This is going to be acidic solution, right? Acidic solution. pH is less than that. That means we are talking about a acidic, that it is acidic nature, right? And then we say when pKa is equals to pKb, when these two values are equal, in that case, this overall value will be 0. That means pH is 7. That means it's a neutral solution, right? That's how, depending upon whether pKa is greater or pKb, which is a... Now, acha, tell me one more thing. If I say that pKa is greater, right? That means which is going to be a weaker one, base or acid? Which is going to be a weaker one? So here in this case, if pKa is greater, that means Ka is less. That means in this case, it is a base is more weak. Base is more weak. That is the reason the nature of the solution is according to which one is more weak here, right? In this case, it is base is greater, pKb is greater. That means base has, see, pKb is inversely proportional to Kb. If pKb is greater, that means Kb will be less. If I say pKa is less than pKb, that means Ka is greater than Kb. That means acid, the acidic part is more strong here and basic part is weak. Wait a minute, have I written the opposite? Yes. Wait a minute. In this case, if I say Ka is less than Kb, so here acid part is more weak. My bad, acid is more weak, right? Here base is more weak. Here the both are equal. Now ma'am, if acid is more weak, then how can it be basic nature, right? If acid is more weak, if I say acid is more weak, then how can it be a basic nature? Then why it is a basic nature? Tell me. Acha, if I say acid is more weak, right? That means the anion part, right? It is more weak. It is less dissociated. Cation part is more dissociated, right? Cation part will be more dissociated. Anion part, acid is, cation part will be more dissociated, right? So in that case, if I say cation part is more dissociated, acid, let's say it is coming from CH3COO negative, this is NH4 positive, right? Now we are saying that here acid part is more weak, both are showing less dissociation, but acid is showing even less dissociation as compared to the base, and that is the reason if dissociation of acid is less, base has more dissociation, more of OH negative ions will be there in the solution. That's why it's a basic nature. Same applies to base is more weak. Now if base is more weak, right? If I say pKb is greater, that means base is Kb will be less. So base is more weak. Base is less dissociating. That is why base is going to give you OH negative. But acid is more dissociating means H positive ions are more in the solution. Right? Okay? Tell me. Tell me, everybody. So it is interesting to note that pH of such salt is independent of its own concentration. pH is not dependent upon the concentration, pH is dependent upon the relative natures of the acid and the base, right? Okay, right? Salt of strong acid and strong base, it is never going to show you any any hydrolysis, because strong solutions will never show any kind of hydrolysis, right? So this is what you need to remember in the end. If you have strong acid and strong base, there is no hydrolysis in that case. Then what is pH? pH is equals to pKw by 2. That is nothing but that is 7. That is a neutral solution, right? When we talk about strong, because strong acid and strong base are going to have complete neutralization. So neutral salt will be there, right? So overall solution will also be neutral. If base is weak, it is cationic hydrolysis. Why? Because in this case, this cation that is through this base, we are talking about that part which is weak part. And weak part is the cation part, and that's why cation is doing the hydrolysis with the water, right? And that is the reason it is called as cationic. When acid is weak, you have anion of acid which is doing hydrolysis, so it is anionic hydrolysis, right? When weak acid and weak base are there, it is called as both cationic and anionic hydrolysis. These are the pH values written over here, right? And acidic, basic, or acidic. Now, when you have both of them weak, that can be acidic, that can be basic, but always when you have weak base, it is acidic. When you have weak acid, it is always basic, right? The one that is weak, right? The one that is strong, that will define whether the solution will be acidic or basic. Here strong acid, so it will be acidic. Here it is strong base, so solution will be basic, right? Okay, now let's see some questions based on it. JEE 2019 question is what? Yes, everybody. JEE 2019 question is what? Tell me, everybody, in the chat box, what is one question module PYQ enough for JEE means while also revising. 11.1 level 2 questions you should go, right? Okay. pH of this much of NH4Cl solution, JEE 2019 question, they are asking. NH4Cl means it is formed from weak acid and strong base. It is strong acid and weak base. Weak base is there, so Kb is also given. So you just apply, concentration is also given. So when you have strong acid and weak base, right? What is the value of KH? That is equals to, I do remember it like this only. KH is equals to KW by whatever is weak, right? And H positive is nothing but it is under root of C into KH, that is nothing but KW by KB into C. And that's how you have the formula. pH is equals to half of pKw minus of pKb minus of log C. This is what you have. This is going to give you 14 by 2. This is minus of pKb is what? Or you can just define it like this. This is half. This is, you can say 14 minus pKb is what? pKb. pKb is not given exactly. So what I will do rather, I'll convert it into, this is 7 because this is 14 by 2, 7 minus half of pKb minus log C. Okay? Or you can just solve it like this. 7, this will be minus half of pKb minus half of log C. Concentration is given, but what is this? This is 7 minus plus, this is half log of Kb minus log C. ठीक है? Log of Kb is what? So log of Kb is what? Log of Kb is going to be minus 5 here. Minus 5 is log of Kb. Na? Kb is 10 raised to minus 5. So log of Kb is minus 5. What about this one? Log of C is what? This is 2 into 10 raised to minus 2. Okay? That will be log of 2 plus log 10 raised to power minus 2, that will be minus 2 here. Okay? You can put it here, log of 10 raised to power minus 2. That is nothing but minus 2. So it will be log of 2 minus 2. Right? Log of 2 is nothing but 0.3 minus 2. Right? So you'll just put this value here, log of C and log of Kb here, and you will get your answer. Right? Okay, put all the values and you will get your answer for this one. Right? And that is the latest question only, so that is important. Next is JEE 2014 question, that is, assuming that degree of hydrolysis is small, right? If I say degree of hydrolysis is small and the pH of this solution will be what? Okay. And here you have sodium acetate. That means sodium acetate means you have CH3, COONA. That means you have it with weak acid and strong base. So in this case, POH is equals to half of PKW minus pKa minus log of C. ठीक है, concentration is given, Ka is given to you. Easily you can answer this. Log of C is what? Log of C. This is concentration here. So log of C is log of 10 raised to power minus 1. That is nothing but minus 1. Log of Ka is equals to minus 5. ठीक है. So pKa is equals to minus log of minus 5. So I'll just write it here. What is the value of pK? This is minus of minus 5. That will be 5. So log of C is minus 1. pKa is 5. So put it here. This will become half of 14 minus pKa is 5. This is minus 1. ठीक है. Minus 1 is plus 1. So it is 15 minus 5 is 10. This is 5. So POH is equals to 5. Then the value of pH will become is equals to 9. ठीक है. Answer will be 9 is the correct answer. Okay. Tell me. ठीक है. What we are doing is we are just applying the formula here. Nothing else. Right? Tell me. What we are doing, students, we are just applying the formulas, isn't it? JEE 2017 question that says, let's see, pKa of weak acid and pKb of weak base. Now we have weak acid and weak base both. Now here third category of formula will be applied. They are asking you the pH. So pH is equals to half of pKw plus of pKa minus pKb, right? So pK value is given to you, that is pK is 3.2, pKb is 3.4. So it is half of 14 plus 3.2 minus 3.4. Solve it and you will get your answer here. This will become 14.4. So pH is 14.4, 7.2. 7.2 will be the pH. Acha, 0.2 na? 0.2. 0.2, 14.2. That will be subtracted. My bad. That will be subtracted. This is minus 0.2 na? Minus 0.2, 13.8 divided by 2. It will be 6.9. Yes. Okay. So answer will be B is the correct answer here. Right? Okay, everybody. So latest question only you can see. Now next question is like this, which is, which of the following increasing order of pH of 0.1 molar solution of compound X, Y and Z is correct? Which of the following increasing order of pH of point concentration is same? pKa is equals to pKb. This is weak acid and weak base. Okay, I'll just see this. Guys, see one thing. Whenever you have weak acid and weak base, right, that is a neutral solution if pKa is equals to pKb. So in this case, pH is equals to 7. I'll just write this here. For X, it is a neutral solution. Y, that is formed from strong base, so it will be basic solution, right? And Z, that is formed from strong acid because of HCl, right? That is going to be acidic. What you have to see here, that this is weak base and weak acid. This is weak base and strong acid. This is weak acid and strong base. So in these cases, so it is fixed that this will be basic in nature, this will be acidic in nature, but there you have to see, and they have given pK is equals to pKb, so you can see that is neutral solution, right? So by that we can say pH of basic solution will be maximum, so Y is going to be maximum. Then it is neutral, and minimum is for Z, that is acidic. So answer is going to be A is the correct answer here, right? Okay, tell me. Clear? Right? So what we are doing is we are just applying the concepts here, right? Now, next is the hydrolysis of amphiprotic salts. Can you tell me what is amphiprotic ions? That can behave both as an acid and a base, right? So in water, it can also accept H positive. It can also donate H positive. Both of this it can do. It can accept H positive, it can donate H positive. Let's say when it is accepting H positive, it is pKa1. When it is donating, it is pKa2. So overall, pH will be pKa1 plus pKa2 divided by 2. That is the value of overall that amphiprotic, that is this amphiprotic, which is accepting also, which is donating also. So in a simpler way, you can say, that pH of the one that is donating, pH of the one that is donating, pH of amphiprotic is equals to pKa when it is donating and pKa when it is accepting H positive divided by 2. Okay, that is going to be the overall answer here, right? Okay, so that is for amphiprotic ions. So you can see this over here. Now in this case, let's say this is amphiprotic number 1. Here its value will be pKa1 pKa2 divided by 2. So value of H2PO4 negative is pKa1 plus pKa2 divided by 2. If I take this amphiprotic, then its value is pKa2 plus pKa3 divided by 2. When it is donating, it is accepting. Both divided by 2. Okay? Right, everybody? Let's see this question here. That is, what will be the pH of the solution of sodium hydroxide phosphate Na2HPO4 given for H3PO4? pK1 is this, pK2 is this, pK3 is this, right? What will be the pH of the solution of hydrogen phosphate? That is this. Hydrogen phosphate means HPO4 2 negative. When it accepts H positive, it will become H2PO4 negative. When it donates H positive, it will become, H3PO4 3 negative. Wait a minute. This will become H3PO4 negative. Here, if it, let's say it accepts H positive, here it loses H positive. If it accepts H positive, in that case, it is going to become H2PO4 negative. If it loses H positive, even this one, it will become PO4 3 negative. Okay? Given for H3PO4, pKa1 and pKa2 and pKa3. That is given. Now what is given? Let's see what is given. For H3PO3, PO4, when it loses 1, it will become H3PO4 negative. Then 1, it become this will become H2PO4 negative. This will become HPO4 2 negative, because it is losing 1 1 na? It is becoming PO4 3 negative. Now, if you see, this is the sequence. This is pKa1, this is pKa2, and this is pKa3 is given to you. What is my major case? They are asking me for this one. And this one is over here. So that means I have to add pKa2 and pKa3. So answer will be pH of HPO4 2 negative is pKa2 plus pKa3 divided by 2. That is 7 plus 2, 7.2 plus 12.4 divided by 2. That is the overall answer here. Okay, so you have to see which pKa to add, because they are asking about this thing, so these two to add. If they ask about H2PO4 negative, then these two to add. Okay, that you must understand, right? Next is, acha, this is the I'll give you for homework. Okay, this is what I will give you for homework, right? So that was about, guys, salt hydrolysis. Now let's finish the last part of ionic equilibrium, that is solubility. And this is one of the easiest part, and it is easy only, so you will not find it tough or something. It is easy because kind of simple questions are there, and it is one of the repeated parts. If you see 2025 also, in 2-3 attempts the questions we could see, and very simple, very direct questions were there based on solubility and Ksp. It was not like some tough question they have asked, but if they ask you like not tough question but still a good question, that will involve common ion effect, right? So I'll teach you with common ion, I'll teach you finding the Ksp value with solubility values, finding the value of Ksp with the concentration values, and we'll see some effects, the how Ksp solubility is affected, right? Okay, so we'll see every single part here. Tell me, guys, all the students in the chat box, do let me know if we can start with solubility or not, right? Let's see, let's start with solubility, everybody. Are you guys awake or are you sleeping in the class? I'm asking you something. Shall we start solubility? Utsav, Vaibhav, then Vandana. Yes, only Utsav is awake. What about others? What about others? What about other students here? Yes, ma'am. Okay. Chal. Now, if you see solubility, the maximum amount, what is solubility? It is the maximum amount of solute that can dissolve in 1 unit volume of the solvent at a given temperature and pressure. When there is a given temperature and pressure, some specific temperature and pressure is given to you, and they are asking that how much in this particular solution, in this particular solvent, how much of solute that you can dissolve here, that can get soluble here, that is called as solubility, right? So there are three categories of salts here that we have based on solubility. First is soluble, which are like where solubility is greater than zero point 0.1 molar, right? Then there is slightly soluble, where solubility is between 0.01 to zero point 0.1, right? Then there is sparingly soluble, right, which is even less than 0.01, where hardly they are soluble, right? And we are talking about sparingly soluble salt here, where solubility is less. It's not like all of the solute that you have added will be dissolved. We are talking about where it is less, where solubility is not 100%. We are talking about that, right? So we are talking about this case. So let's talk about Ksp and the value of Qsp. Two things are there. First is solubility product, that is Ksp. Now it is just like equilibrium you have, right? You in the equilibrium you have Kc and Qc. Kc is when you put the concentrations of equilibrium, then you call it Kc. When you put any other concentration except for equilibrium concentration, that is called as Qc. So in this way, what we have, if I talk about solubility product, right? Solubility product simply means that you have Ksp, that is in this Ag positive and Cl negative are equilibrium concentrations, right? Okay. But when the reaction is at equilibrium, the above product is called as Ksp, but at any other state, it is called as ionic product. Just like in any other state, you have reaction quotient, here you have ionic product. Okay. So if I say solubility product and ionic probability, then we can say, if I say Ksp is less than ionic product, that means Ksp is very less like than ionic product. Ksp is at equilibrium, this is the ionic product, right? The ionic product is greater, right? When the ionic product is greater, it will move in the backward direction. In the backward direction, tell me what is happening. In the backward direction, solid formation is there, isn't it? In the backward direction, precipitates will be formed, right? So backward direction means precipitate formation. When Ksp is greater, so this is Ksp, this is ionic product. You have to increase it to make it equal to Ksp. So when you are increasing it, they will be at the same value. So now you can say when you are increasing it, they are at the same value. Now it is called as, now we can say it is moving in the forward direction. That means this direction will be there, more dissolution will be there. That means here we can say that more salt is dissolved, right? Okay. Then the third one is when Ksp and ionic product are equal to each other, then these two things are equal to each other. This is Ksp, this is ionic product, they are equal. This reaction will not move forward or backward, right? So we can say this is at equilibrium, right? Okay. These 2 points are very important. They can ask you this thing, right? Okay. Now let's see, based on solubility, how you will define the value of Ksp, right? So if I say this reaction is given to you Ax into, chalo, I'll just write it here myself only, otherwise even I feel, acha, see this thing now. If I say this is Ax, By give rise to Ax, and here it will be Y will be here, so it will be Y positive, and this will be X will be here, it will be By, no. Well, actually, because this will dissociate into Ay positive, how many times? X times, and this is Y times Bx negative. Okay, because all the salts are formed by cross multiplication, right? Now if you see this here, right? Now if you see this here, what is Ksp? Ksp is product by reactants. Product is Ay positive raised to power X. This is Bx positive raised to power Y. And this is a solid, so we don't need to write it, right? Okay, that means this is the first way of writing. Now, another thing that you must know, I'll just erase that only. I'll erase that and write it again, because now you need to convert it into solubilities. If I say, initially here it is S, this is 0, this is 0. Just like we used to write concentration, here we are writing it in the Ksp is written in the form of solubility. Kc is written in the form of concentration, Kp is written in the form of pressure. So Ksp is written in the form of solubility. So we'll write solubility here, right? So all of this is dissolved. This will become S and this will become S, but here it will be multiplied by stoichiometry. So like this. So if I write the value of Ksp, that is equals to cation, that is A y positive raised to power x, and this is multiplied by B x positive x negative, right, raised to power y. Okay, now ey positive is nothing but it is x into x. Its concentration is x into s raised to power x. This is y into s raised to power y. So this will become x raised to power x, s raised to power x, y raised to power y, s raised to power y. This is nothing but it is x raised to power x, y raised to power y, solubility of x plus y, right? Now this is, I told you that how to solve this, because this you must know, because sometimes solubility is not directly given, then we have to solve it like this, right? Now I'll give you that how directly to answer this, right? How I should directly write this value here, how without doing all of this I'll directly write the value here. Solubility is S. It is given in the question that solubility is S. Right? How do you write it? Write Ksp is equals to stoichiometry raised to power stoichiometry, stoichiometry raised to power stoichiometry, solubility raised to power addition of stoichiometry. Okay? So if you know this simple trick, with this you will be able to solve these questions in seconds. Right? Okay, and if no calculation is required, then it will take hardly 2-3 seconds, right? Okay, right, everybody, tell me, is that clear? Real, actually I don't remember right now in which lecture I have discussed that, so that you'll have to go through, right? You'll have to see that, right? Acha, see, that is done. Now let's see some questions based on it. The question is, first question is, you have JEE Mains 2019 question that says if solubility product of this is denoted by Ksp, its molarity molar solubility is denoted by S, which of the following relation between S and Ksp is correct? So it's quite simple. You just have to dissociate it. Zirconium thrice PO44. So it will be dissociated to cross multiplied on zirconium. You will have 4 positive and it is 3 times. And this is, you will have 4 times PO4 and this will be 3 negative here, because 4 will be here, 4 positive, 3 will be here, 3 negative. Okay, that's how you write it. Now what you have to do is Ksp is equals to stoichiometry is 3 raised to power 3. It is 4 raised to power 4. This will be solubility of 4 plus 3, right? Okay, 4, 5, 6, 7. So this one and this one is already ruled out. So this has to be like solubility has to be solubility is 7. So Ksp has to be 1 by 7, right? Now you can also calculate this, whether it should be on the value of 6912, whether this multiplication factor, so I'll just write it here, 3 into 3 into 3, 27, right? 16 into 16 is, I think, 216. So definitely this will also not be the correct answer. You don't even have to solve it. From this only you can say that D will be the correct answer here. So it is just 2019 question, not a very old question. You can solve this within seconds, right? So that's how you do it, right? Now this multiplication and all, you don't have to do it. What I told you, when solubility and Ksp relation is given, just do this. 3. Stoichiometry raised to power stoichiometry, stoichiometry raised to power stoichiometry, solubility of addition of stoichiometries. Now you know that 4 into 4 is 16, 4 into 4 is 16, into 16 is 216. So definitely 216 will be multiplied by 27. So here definitely it will be greater than 216, right? Okay. Now next question is, they have given 2012 question, that is, now here they have given, let's see, the solubility of PbI2. Let's see if you can answer this or not. Let's see if you can answer this or not. The solubility of PbI2 at 25 degrees Celsius is 0.4612. Achha, remember one thing, this is gram per liter. And molarity is nothing but number of moles by volume. So molarity is mole per liter. Remember this always. This is a very small mistakes that students do. Molarity is mole per liter. And strength is gram per liter. So how do you convert strength to molarity? Molarity is equals to strength is equal, molarity is equals to strength divided by molar mass. Okay, that is the relation that you must know. This is the relation that you must know. Okay, right everybody? Acha, now see this. The solubility of PbI2 is this. Okay, solubility is given to you. Solubility is given to you. Okay. The solubility product Ksp they are asking. Dekho. Molar mass is also given to you. So write molarity will be equals to molarity, or you can just write solubility in terms of, because when we are using that, I am using molarity in terms of solubility in terms of mole per liter. Okay, so I'll just divide the strength, that is 0.4612 divided by 461.2, and that's how you will get your solubility here. Then see what is the value of Ksp. Ksp is nothing. If you see Pb I2 give rise to Pb 2 positive plus I negative. So it will be 1 raised to power 1, 2 raised to power 2, solubility raised to power 2 plus 1, that is 4s cube. So 4s cube, this is S solubility, you can solve this. So when you solve this, this will be 10, this will be cancelled, so it will become 0.001. Okay, then put this value and you will get your answer here. Okay, put this value and you will get your answer here, right? Solubility is coming out to be 10 raised to power minus 3, that is 0.001. Put this value here and you will get your answer, 4 into 10 raised to power minus 3 cube. So it's 10 raised to power 339, 4 into 10 raised to power minus 9, right? So answer will be 4 into 10 raised to power minus 9. Okay? Okay, so here if you see, the problem was that here where students could have made the mistake is here on this part. Because of this units here, they could have made the mistake, right? Okay, now let's see the next question here, that is 2020 question, that is based on, let's see which thing. Everybody, let's see if you can answer this or not. Everyone in the chat box, let's see if you can answer this or not. Right, students, let's see if you can answer this or not. Now the KSP for the following dissociation is this. This is given to you. Which of the following choices is correct for a mixture of 300? Okay, KSP value is given to you. QSP value you have to find it out. So QSP is also same. Huh? QSP is equals to what? Concentration of Pb2 positive raised to power 1, Cl negative raised to power 2. Okay, because of this product by reactants. Reactant is one only because it's a solid. Now molarity is given to you, mixture of which of the choices are correct, mixture of 300, volume is different. Okay, Pb2 positive is coming from this one and this is coming from this one, right? So here 300 of point this molar, this is 100 milliliter of this molar. So that means that here number of moles are going to be different. Okay, beta Shiva, what do you think that I go to students' houses and I go and tell them, go, I'll pick you there and drop you there in my class, right? I don't do that, right? So how can I tell? है ना? How can I tell? It's maybe because right now, na, students are busy in their own studies as well, right? These sessions so I am taking for JEE 2027 aspirants, right? Tell me, everybody, what will be the correct answer here? Right? How do you answer it? Tell me. Concentrations of Pb2 positive, and this how you will get. Concentration of Pb2 positive is, firstly, number of moles of Pb is going to be molarity 0.314 multiplied by volume in milliliter. These are millimoles, okay? And if you want to calculate the concentration of Pb2 positive, this will be millimoles, that is 0.314134 multiplied by this divided by volume. Volume, overall volume is 100 plus 300 plus 100, that is 400. Similarly, the volume, the concentration of Cl negative is going to be molarity multiplied by volume, that is given for NaCl, divided by overall volume, that is 400. Now solve this, put these values here, and then you have to see what is the value of QSP. Is it greater, is it less, or is it coming out to be equals to this thing, right? Okay. Yes, everybody, you can see this over here. This will be cancelled and this will be equals to 0.1 and this will be equals to 0.134 multiplied by 3 by 4, right? Solve this here and get your answer. You can solve this. This is also coming out to be approximately 0.1 only. This is also 0.1 that you can see over there. So when you put the values, this is 0.1, this is 10 raised to power minus 1. This is 10 raised to power minus 1 raised to power 2, that is 10 raised to power minus 3 is the overall value. And here this is 10 raised to power minus 5, so that is definitely smaller. So you can say QSP is definitely greater than KSP and hence the answer is going to be C is the correct answer here. Okay, right? Now the next question is JEE 2018 question. Let's see that. What is that, everybody? Let's see this question as well here, right? Okay. An aqueous solution contains an unknown concentration of Ba, right? When 50 milliliter of 1 molar Na2SO4 solution is added, BaSO4 just begins to precipitate. Now here what they are saying, 2018 question it is, an aqueous solution of point contain this unknown, wait a minute, an aqueous solution contains unknown concentration of Ba2 positive concentration, you don't know, Na2SO4, from where SO4 is coming, that you know, when solution is added to BaSO just begins to precipitate. For this now, firstly you should know common ion. Firstly, I would want you to do common ion effect, right? Okay, so let's do this question after this. because eventually then you will get confused in the end, right? So firstly, let's do these things. Factors affecting solubility product, right? Firstly, let's do these things. First is common ion effect. Common ion effect is when you have CaF2, right? It is being dissociated to Ca2 positive and F negative. Now let's say you have added Ca2 positive or F negative extra from some other compound. Let's say I have added NaF. Now F negative is also adding from this NaF. It is also there from CaF2. CaF2 is already in the solution. So these ions are already there in the solution. If I add a common ion compound, that is fluorine is also here, fluorine is also here. So fluorine is the common ion, the concentration of fluorine will increase. When the concentration increases, according to Lee-Chartler principle, when product concentration starts to increase, it will go in the backward direction. That means it will start forming precipitate. So we are saying addition of whether this or this shift the equilibrium towards the left side. That means reducing the solubility, it will move in the backward direction. So you can say it will move in the backward direction according to Lee-Chartler principle. It is right. According to Lee-Chartler principle, you can see it is moving in the backward direction, right? Now how do you solve it in the exam, right? Very simple. NaF, let's say we have added NaF, the common ion which is strong. One of them will be weak electrolyte, one will be strong electrolyte. Strong electrolyte, they will give you that we have added. Let's say they have given you 0.1 of NaF. So because it's a strong electrolyte, 0.1 of Na positive, 0.1 of F negative will be formed. In case of CaF2, initially it is S, it is 0, it is 0. Now in this case, we are saying 100% dissociation, dilution is there. This is stoichiometry multiplied by S. This is also stoichiometry. Initially, let me tell you, initially it is not this. Initially it is not this. Okay, initially it is not this. Initially it was, here it is 0.1, here it is 0, here it is 0. This will become 0, this will become 0.1, this will become 0.1. Initially this is S, this is 0, this is already 0.1 in the solution because of this common ion here. So this is becoming 0, this is becoming S into 1, this is becoming 2S plus 0.1, which is this solubility is so less that it becomes approximately equals to, like, degree of dissociation you can ignore solubility. Here it is approximately equals to 0.1 only, right? Okay, so here that is the reason your answer will differ here. Here Ksp value will be equals to solubility raised to power 1, that is Ca2 positive raised to power 1 and F negative raised to power 2. So it will become, this is solubility, this is 0.1 square. This is the value of Ksp that you will have. Okay, this is all because of the common ion that you have. So all because of the common ion. Now answer of Ksp is going to differ. So in common ion, you can't apply that trick, stoichiometry, raised to power stoichiometry, that you can't apply that. In case of common ion, you have to solve it like this, right? Okay. Now let's see effect of consumption of ions. There we told if some extra common ion is there. Here we are saying if there is some ion that is being consumed, the solubility of a slightly soluble salt is increased by presence of second solute that reacts with one of them. If there is some solute that is eating this, you are eating this, you are eating this, you are eating this concentration is getting decreased. And according to Lee-Chartler principle, whenever the concentration are decreasing, it will try to increase it. It will move it in the forward direction. So solubility will increase, more dissolution will be there, right? So we can say that if one of them decreases, then we can say solubility is increased in this case. If ions are being eaten up by someone else, right? So addition of NH3, shifts the equilibrium forward. Why so? Because NH3, it has lone pair of electrons. It will eat up Ag positive, right? It will form a complex here. And complexes are stable. More is the stability of this complex, more Ag positive ions will be eaten up by ammonia, less will be the concentration of Ag positive here, and that is why according to Lee-Chartler it will move further in the forward direction, so it further increases the solubility here. This is the example of what we discussed here, right? Okay. Next is effect of complex formation. If complex formation is there, we have just discussed that, na? Same thing. General rule is that solubility of metal ions increase in the presence of solubility in the presence of suitable bases like these is provided the metal forms a complex with the base. For example, same situation, you have ammonia. If ammonia forms, it reacts with one of the cations here, and they both are forming a very good complex. That is because this complex is formed, so Ag positive will decrease according to Lee-Chartler. It will move forward, solubility will increase. Right? So that is the reason. If a complex is formed by a Lewis base with the cation here, then definitely it is going to increase the solubility here. Right? Okay? Tell me, is that clear? Now let's discuss 2-3 questions based on that. Okay, firstly I'll discuss that. Now this is the last part that we have. Firstly I'll discuss this question that we had. Okay, 3-4 questions we are going to do. Then the chapter will be completed. Right? Okay. Ma'am, why it is written increasing solubility if it is in the forward, if it is, let's say it is AgCl, when it is soluble, it soluble means it will get converted to ions. So in forward direction solubility is increasing now, in backward direction solid is getting formed, that means precipitation is increasing, right? Okay, tell me. If you have this, let's see. Here in this case, an aqueous solution contains unknown concentration of Ba2 positive and 50 milliliters of NaSO4 is added. This just begins to precipitate. That means it start moving in the backward direction. Right. The final volume is 500 milliliter. Ksp of BaSO4 is given to you. What is the original concentration of Ba2 positive ions? Okay. Now you will assume the original concentration, right? This is the common ion that you have, and Ksp value is given to you. Okay, let's do, you can do it. See, if you talk about NaSO4, that will give you 2 of Na positive and SO4 2 negative, right? Now if you see this here, the concentration of NaSO4 is given to you, right? Be it over 50 milliliter of 1 molar, that means concentration and molarity both are given to you, right? Now if you see this here, 50 milliliter of 1 molar, so just begins to precipitate. The final volume is 500. Final volume is this, na? Okay, see this thing here. If I say this is 1 molar and this is 50 milliliter, okay? 1 molar and this is 50 milliliter. Then I can say the number of millimoles here will be 50 millimoles, right? Then after this, this is also 50 millimoles. This is also 50 millimoles, right? Once this is done, then both are 50 millimoles. Now common ion is SO4 2 negative, right? So we need to see what is the concentration of SO4 2 negative. Now, if you see SO4 2 negative, right, overall volume, final volume of the mixture is 500. And what is molarity? Molarity is millimoles divided by volume in milliliter. Volume is 500 millimoles from SO4. From Na to SO4, it is 50 millimoles divided by, this is nothing but this is telling you millimoles, right? So divided by total volume, that is coming out to be approximately point. But nothing, we have just applied this particular formula here, that molarity is equals to millimoles divided by volume in milliliter. So millimoles I have calculated by multiplying molarity into volume of Na to SO4, that is 50. So this will be 50, this will be 50. Now millimoles are divided by total volume. If you see this here, molarity is nothing, millimoles by total volume as well. Right, so you can see this is overall molarity. Now this was not given to us in the question, right? This we have calculated to be 0.1. Usually it is given in the question, but here it was not given, so it is 0.1. Now we know that the common ion, it is 0.1. For just precipitation to begin, right, we know that Ksp and Qsp can be approximately equal to each other. So we can say Ba2 positive and SO4 2 negative, right? Ksp is given to be what? Ksp is given to be 10 raised to power minus 10. So you can say Ba2 positive, SO4 2 negative is this. This is 0.1. This is given to you. From there, you can calculate the concentration of Ba2 positive, right? Now, for the original Ba2 positive, we know that because you are like you are adding two things, right? So we can say M1V1 is equals to M2V2. Now, when the volume is 500, when I say the volume is 500, then it is 10 raised to power minus 9 that we have calculated here. When SO4 2 negative is coming from this, right, Na to SO4, it is 10 raised to power minus 9, right? And before this, because see, 500 is the total volume, out of which 50 is coming from this Na to SO4, because Na to SO4 has how much volume? 50. Right, so it is becoming 500 minus 50, that is volume of BaSO4 must be 450 milliliter, and that's why we have put it here that M2V2, this volume is 450. When it was 450, what is going to be, what was the molarity that we have calculated here, right? Okay, tell me guys, is that clear what we have done here, right? Thank you, Rasik. I really hope so. I really hope so. That's why I know that sometimes students don't join the live sessions, but they watch it on the recorded version. So that's why I'm like, okay, whether students are there or not, I'll teach, because some students are there whom time does not suit or so whatsoever. Then they watch it on the recorded version, right? So what is there? Na2SO4 50, BSO total is 500, so BSO4 will be 450, right? Okay, here you have calculated firstly how much ions, SO4 2 negative, and this, what is the millimoles here, right? Then in the total solution, it will be molarity, this much. If this is the molarity, then when you put it here, 0.1, this is 10 raised to minus 10, you get the concentration of Ba2 positive, right? So this Ba2 positive with 500, this molarity we don't know, but volume will be 450, and hence you can calculate that, right everybody? Okay, that was a very interesting question, right? Now let's see some more questions here based on solubility. That is JEE 2019 question, that is, which is the molar solubility of AlOH thrice in 0.2 molar NaOH solution, given that Ksp of AlOH thrice is this. Now, common ion is definitely, we can see this here, which is the molar solubility. Solubility, they are asking you of this. Ksp is given to you. So what you have here, you have AlOH thrice. Okay? Easily, this is Al3 positive plus 3 OH negative. OH negative, see, from here it will be solubility S, it will be 3S, and OH negative ion will also be given by 0.2 of that, which is approximately equals to 0.2. So you can say Ksp is equals to solubility multiplied by 0.2 cube. Ksp is given to you. Ksp value is given to you, that is 2.4 into 10 raised per minus 24. From there you will calculate the value of solubility here, right? So just put all the values here. Ksp is equals to solubility to 0.2 cube. Now this I told you how you came to this point. Now put all the values and you will get the value of solubility there. Okay, it's just about the calculation after that. Now last question of today, let's see, that is 2019 question. Last question is. Last question of today, that is 2019 question, that is Ksp of Ag2CO3 is this, the molar solubility of this in 0.1 Ag. Again, it is based on common ion effect. Ag2CO3 is converted to 2Ag positive plus CO3 2 negative, right? Now from Ag, they are saying Ag is this, is the molar solubility of Ksp is this, molar solubility is this, the molar solubility of Ag2CO3 in 0.1. Okay, this common ion is AgNO3 is given to be 0.1. So that means Ag will be also, this is 2S, this is S, but this will come, Ag positive will come from AgNO3 as well, that is approximately equals to 0.1. So the value of Ksp will become 0.1, that is for Ag square, this is S. So now Ksp is given to you, solubility you have to calculate. So solubility is equals to Ksp divided by 0.1 square, that is nothing but it is multiplied by 100. So it is 8 into 10 raised per minus 10, right? So it's quite simple, quite easy. Answer is C is the correct answer here. And these are not very old questions. They are asking you latest only based on solubility. Ionic equilibrium is considered to be very hard topic. Even I also made a short on that. Even I said that ionic equilibrium, students find it difficult because a lot of formulas are there, a lot of concepts are involved here, right? And every single section is important. Sometimes they ask you from solubility, sometimes they ask you, you have seen this yourself that I am taking latest PYQs only. I have taken it from buffer solution also. I have taken it from pH of acid bases as well. I have taken it from salt hydrolysis as well and from solubility as well. So these four topics, it's unpredictable that from which topic they will ask you the question. So all the four topics you have to do right in detail. Right, everybody? Yes. Okay. Yes, AgNO3 is a strong electrolyte. Yes. Okay. Chalo. Salts are strong electrolytes only. Right? Okay then guys, that's it for today. Now this is your homework question. Write it there. And I want all of you to do the homework question in the comment section. And if you see this over here, everybody, see this over here, then in the description box, right, wait a minute, I'll just, where is our today's session? And also tomorrow in the morning, 6 a.m. I'll be taking your CYQs of chemical kinetics. No, sorry, solution chapter, right? I'll be taking, wait a minute, let me just, I'll be taking your CYQs of solution chapter, right? So if you see this over here, right, over here, you come over here, and here in the description box, you will see this is, you will see over here, click on this particular thing, that is Eclavia Booster Test Series, which is right now available at just 999, right? And 80% off is there. Here you are getting 11 part test, 25 full syllabus test, and 75 question in each test of 3 hours, just like your JEE main paper, along with 93 high weightage topics, right? We are doing there, right? So every topic will have a specific test, that is including 93 plus 11 plus 25, so you can calculate yourself. That is available at just 999 rupees. Okay, everybody, right? Chalo, now I'll see you all in the next class. Till then, bye bye, take care. Bye bye, everybody.